Hey guys, Jeff here, and welcome to my Forever Home series. In today's video, we are tackling structure. We're talking about how we replaced the whole load-bearing wall down here in the basement with post and beam, all right? And why we had to do that. Now, this was a 1974 home. It was built before building code. We opened the floor for the plumbing and found it insufficient structural underneath. So what we did is we contacted our engineer to make all these changes so we could do this up to code and better than code. So if you're considering making major structural changes in your house, this video is going to answer a lot of those questions. Let's just jump right into this. So let's just talk about the footings for a minute, because this site has two different requirements. One is a 2x2 foot footing, 8 inches deep, and the other one is a 3x3 foot footing, 10 inches deep. This footing here is also built differently. As you can see, we just excavated with a shovel and down to our depth, and we didn't have to do any reinforcing. This one here was a little different. At this location of the floor, it was all stone. It actually goes almost 12 inches in stone. And so our walls were caving in. And the nature of clean stone is that when you're digging, it collapses and it creates that pyramid. And so if we go 8 inches down, it also means 8 inches underneath this over here is no stone either, right? It starts to slope down. So what I did is I built the box, set it on the stone, and while I'm putting weight on it, I dig out the stone from underneath of it, okay? And just went around, and slowly sunk it into the ground. And that did a great job of maintaining most of the stone. Also inside of them are these little plastic chairs. I'm gonna show them here. They're designed for the rebar to sit on the bottom and then come across and clamp in at the top going the other direction, okay? So you throw those in, and the purpose of this is just to keep the rebar off the ground in the middle of your concrete mix, all right? My engineer has actually called for me to use 5 bars. The other people, they made the structure. They just put a couple of little pieces of concrete underneath the floor, 1 inch thick. That's not gonna carry the kind of load we're looking for. What if down the road somebody says, hey, I would really love to be able to do this, or put a grand piano or something in the house, and right? We want to build this structure to like really be forever proof, right? It's my forever home. I want to forever proof it. So we're going with twice as much rebar, and we're going to tie them together using zip ties, because I am not a fan of twisting wire. Now, if you're in the concrete business, then you've probably went out and bought yourself a little power battery tool. Milwaukee makes one for sure, and it has the wires, and you just clamp the 2 crossbars together, and this sets the wire so that the bars aren't moving around, okay? So zip ties are a great solution for that. Now, the rebar itself comes at the store. If you go to the local Home Depot, it comes in a variety of sizes, 2 foot, 3 foot, 4 foot. Depending on their inventory, they may not have what you want. So for us, they didn't have any of the 2-footers, so we actually have to cut this sucker. That's as simple as getting a measuring tape and a marker. There we go. Here we are. We're going to measure the 24 that we need. Whoop. And just to get a reference point so when we start cutting, we're in the middle. And might I suggest, if you're going to be digging no footings, you're going to have gravel and you're going to have dirt, clay or sand or whatever it is. Grab these Brute garbage cans. They come with the wheels. You can get them at the Home Depot. You can have it right next to where you're working. And then when you're done, you can roll the darn thing out of the way. I'm using a basic 5-inch metal cutoff wheel on my grinder here. And I'm just going to hold it and then cut this free. You'll notice I'm going to start cutting from the side, and it throws everything in your face. If you start cutting from the top, it'll actually throw everything forward out of your way. Use your thumb kind of like as a guide to hold it to 90 degrees. You'll have great success. The right way. And when it's almost cut through, it just bends in half. Now this is a really good coated steel, okay? Don't get confused and pick up the fiberglass option. You'll fail your building inspection. And this is one area of the inspection where the city is gonna come by and they're gonna wanna take a look. Make sure you got the right size, the right depth, and the right amount of steel, and the right size of steel according to your structural engineer drawings. And that's as simple as it is. And we're prepped for pouring. Now, my drawing calls for 5 bars, and I'm going 5 by 5 instead. Just because, like I said, I want to overdo it. Just throw a couple of zip ties on these other bars here, so nothing is moving around. And I'm using a pair of side cutters to trim them down. Okay, and that is my preparation process for mixing cement. The way you want to do this is you want to have 2 zip ties for each piece of steel. All right, so this machine plugs into any wall plug. This is a rental from Home Depot. It's designed to go into a 15 amp circuit. We got it hooked up to a 20, and it's just slow and consistent, right?
Yeah, I think, I mean, you can maybe find a couple of them that come in different, like, variable speeds.
Yeah, there's definitely more contractor grade tools out there, but this is really designed for the homeowner. So it's a little slower than what you're used to working with, but it did a great job over there. Yeah. All right, so let's see your system.
Cool. Hey, YouTube, you know, I'm not teaching you how to mix concrete in a concrete mixer. By no means am I a pro. I kind of just picked up a couple of things along the way. So I'm going to show you how I do it. And for all the pros out there, if you guys have any tips on how I can get better at this kind of stuff, just let me know in the comments below.
Yeah, that'd be awesome.
Yeah. Anyway, so to start off, I like to have my concrete barrel a little bit more wet before the concrete goes in, just because I find that the concrete will build up on the bottom, which kind of sucks to clean once you're all done. So I'm going to go ahead and start doing that. Get this puppy on. So again, I just try to wet the sides. Get about half a pail worth of water in there, because I'm going to be mixing around 2 or 3 bags worth per bucket of concrete mixer. So get it all soaked up nice and good. Grab our bag.
I just wanted to add one thing. If you're using this machine, you'll see these pieces here on the side, okay? If you are wearing a ring or loose clothing and you get caught on that, this is not going to slow down until it tears your arm off, okay? Yeah. So work from outside the bin.
So now I just completely saturate the inside of the barrel. I want the rocky sounding to go into more of like a slurry slush sound. That's how you know that you're getting enough water in there for the next bag. Almost there. Again, while I'm adding water, I'm trying to clean off the sides as I go, just to make it easier for the end of the day when I'm done using the barrel. All right. Bag number 2. All right, now we're gonna let it mix up. The goal for me is to have the concrete coming through those little holes on the side of the fins to kind of make it look like toothpaste or a sausage link's getting created. That's kind of the rule of thumb that I go by, and that looks like concrete that's just about ready to be poured in for me. So. Perfect. You want to go 3?
No, you can, because then there's only 2 batches and this hole's done.
All right, so now that we have our desired consistency, you can see on the inside of the drum that all the excess concrete's been washed out and kind of made a part of this formula. So now I'm just gonna keep the machine on, tip it over, and pour it in the hole. And then lastly, I just clean it again for the next bag. So this might not be a perfect process. It worked out pretty well for me yesterday. I did about 25 bags of concrete worth using this method, and I did all the concrete on the floor over there. So anyway, I kind of spread it out, smooth it out, and it looks like we'll use 1 or 2 more bags to fill it up, trowel it out, and we'll have a pad.
Yeah, so what I'm gonna do, Matt, is I'm gonna take the framing out now.
Okay.
All right, and then we'll be able to get that to the right height.
Okay.
Okay. There we go.
Can you explain why you did that again?
Yeah, so you can see all this rock. It was all caving away from this wall, you can see that. And so what we did is we wanted to get this in here first. Now I can use my trowel. Push the concrete back up and backfill underneath the floor. Make sure that every area of this floor is now supported with something from underneath, whether it be the stone or the concrete.
What do you think? We need another 2 bags, or do you want to go 3?
Go 3 because I pushed it all up underneath.
You said 3?
Yeah.
Okay. Yeah, we need another bag.
I think we'll need another bag for this one. Okay. I've also got picked up the Husky magnesium float. This is a handheld tool, okay? And I like this for finishing because it has a rounded edge. All the other tools out there for concrete were square, and the bottom wasn't flat, it was like curved. And I'm like, I get that, but for what we're doing, we're just trying to not leave ridges that can be affecting our subfloor system later. And I cut down a piece of 2x4. We're gonna fill it, and we're gonna use this. Just slide it back and forth. Make sure we're flush to flush. Extra material we'll throw in the other hole. Can you just spray down the top and the sides so that everything gets a nice bond? Make sure we're not trying to adhere old concrete to dust. Yeah, exactly.
Okay.
Yeah. Concrete bonds to wet concrete better than dry concrete.
Fair enough.
All right. Okay, hold up. That was 1 bag, right?
Yep.
Yeah, you better stop there. You put the whole bag in?
Yeah.
Okay.
We need, that might be perfect.
It might just be so perfect it's scary. All right. Let's give this a try.
Yeah.
I got voids.
We need 1 more.
We need another bag.
All right.
And don't give me the whole load. Just give me, pour it into the shovel almost.
Here it comes.
Okay. Just leave that running for a minute. I'm going to screed this now. Okay, give me some more. Okay, Matt, I think that might be enough to do it. Yeah, I'm gonna need another bit of a shovel. Go. There we go. So what I'm doing is I'm not holding it flat, I'm holding it on the lead edge. It's a little bit easier to keep off the rocks. want to make sure I'm screeding from a high place because I've got this low channel in the back here. Now, as long as there's enough material in there, I'd keep the mixer going until you empty it out, or it'll just settle down on you.
Okay.
Okay. I'm close enough there now. Now we're just going to tool it. Just really light pressure. This will allow more of the Portland and sand to come to the surface. Again, the more perfect you want to try to make this look, the more time you spend tooling. You can let this harden up for about half an hour. Come back and tool it some more. I've got tool failure, right? That coating that's on the bottom of this is starting to peel off. Well, there we go. That's a patch, right? Now all the stuff around the edges, you can come back later and you can just scrape the extra off. Not a big deal. Brilliant. Okay, we got 2 more footings to pour. Probably another 20 bags because the big 3x3 is also a lot deeper. Now, when you read the back of the bag, it tells you that it's okay to walk on after 6 hours.
It's 24 hour for foot traffic.
24 hour for foot traffic?
Mm-hmm.
I usually do 6. I break all the rules. Okay, experience is different than the bag. And then in my experience, we always would come back the next day, set all of our posts and beams, and not take away our temporary load structure for 3 days. You have a curing process with concrete, and the goal is to try to keep it as wet as possible. So depending on your job site conditions, you might want to come back the next morning and even mist down the floor or throw plastic over top of it to help trap that moisture, okay? So there's a couple of different ways that you can achieve that, but generally after 3 days, the concrete itself at 2 inches thick is going to give you about 2,500 pounds of strength. All right? That's PSI. With the rebar, it like triples it. And as thick as we have it, we're up in over 10,000 easy. With the rebar, we're probably at around 15 to 20, which gives you an idea of the load that my engineer is calculating for the point load for that 25-foot beam going down the center of the house. That goes to a 3x3, 10 inches deep. He's making sure that that is never, ever going to have an issue.
Hopefully not.
That's insane.
Yeah.
This pad is poured just to handle a post here that'll pick up 2 LVLs, that'll carry all the load from this floor, and then a post to the outside wall, which goes down direct on the concrete over the footing. And what he's expecting there is that the concrete, crushed stone, dirt footing is compacted and will translate that load. Huh. Wild, huh? Mm-hmm. Because the idea here is whatever flooring I'm using in the bathroom is going to be tile, and we want to make sure that this floor is never going to move again. That's why we're going extreme. If I just did a regular wall on this concrete, I probably would have got away with it. If I didn't tear the walls out, we probably would have got away with it. But this is my forever home, and in this job, we are going over and above and beyond, overkill in every regard, because I'm going to live here and I don't want to have to do anything twice. So better to go back to the beginning, open some holes, pour some proper footings, get a proper load-bearing wall down the middle of this house that we know isn't going to sink or sag or move. So whatever finishes we do upstairs, we can use a laser level, we can use premium finishes. Everything's going to be perfect. All right. Hey guys, welcome back. Here I am standing on my pad. It has been at least 3 days. It's actually been closer to 5. To film this one, we actually had to wait a few days because this is going to be a point load. And since it's carrying weight, we want to make sure that it's cured to the point where the PSI or the strength of the slab is increased over the course of 3 days. Now that we got that done, it is time for us to rip out this wall and put in our post and beam, and then we can backfill it. We'll get all that in just a second, but I got my drawings from my engineer and my designer here, and I posted them on the wall. And I wanted to just bring you over, walk you through that. It'll probably help you visually to see exactly what's going on in a drawing form, because this is very confusing. All right, so why don't you come on over and I'll show you what we're doing. Here we are. This is our floor plan for the basement. Stairs stay in the same position. We're building out the existing stairwell and then putting on that wall to create some privacy for the living space. Very nice. And then that'll walk right into what will be called a billiards room. We just called it a billiards room for now. Let me know what you think. Should I put in a pool table? Anyway, here we are. This is the wall that I'm building today. Right here. It's a separation wall. And I want to have it soundproof. We're going to go 2x4 because that's the same width, a 2x4, as 2 LVL beams. And then we are going to insulate that wall and then put our soundboard over top of that before the drywall. And we're going to get a really good acoustic rating on that, so it should be more than enough from bedroom to office. Now, we also have another bedroom down here, then the bathroom, which has been moved over now, and then we've got a laundry room and a mechanical room, and that's that. So now we can take a look at the engineer drawings, and hopefully this makes a little bit more sense. Now in this video, we're tackling our post and beam. So I need a structural load wall here, because all the joists meet in this area, coming from this direction and this direction. I need a structural wall here to carry all the joists that are coming from this direction and this direction. That represents load bearing for the entire length of the building, okay? And that is what we have to do. So once we tackle that, that's 1 post, 2 post, 3 post, 4 post location for all of that, then we can also tackle, in another video, building up our structural load. These two go upstairs all the way to the peak of our new ceiling. That's another day, but now we walk around here and we go, all right, so we got post location. Well, here's a P4, that's a P3B, that's a P3B, 3B, 3B. What's the difference between a 4 and a 3B? Let's take a look. A 3B is 4 2x4 posts, okay? And a P4 is only 3 2x4 posts. So oddly enough, this is only 3 posts. This one's gonna be a 4 post. This one's a 4 post. This one's a 4 post. This one's a 4 post. And this one's only a 3 post, which means these ones are all really strong and these ones are weaker. And here's why. This is my point load coming from the roof, picking up my new vaulted ceiling beam. It's 25 feet long. It's going to carry a lot of load. But this is also the other one for that same load. And then there'll be another beam in the roof line, okay, up in the attic. Now, because this one is really close to where the beam location is, it carries the majority of the load, all right? And because there's a beam that goes from here to here, this one also is going to carry the majority of the load. So they both have to be overdone as far as their post size. Because this is 10 feet long, he's upsized the post size for this one as well. Okay, these stretches are all 7.5 or 8 feet. And that means this one hardly carries as much load and it can be downgraded. This one doesn't carry much load, it's downgraded. All the details are right here in the structural legend about all of the different requirements, all right? So now we got the story, now we got to do the work. Because the designer says, hey, make it look like this. The engineer says, here's the structure, what it has to look like when you're finished. And then there's only one inspection that happens in all of this process, and that is the city inspector comes and looks in the hole to make sure that the footings that they've called for are dug the right depth and with the right amount of bars, minimum, okay? We went a little deeper, we went more bars. So she was really happy with that. Now we have to get to the end game now, and there's no rules for how to get there, okay? And this is why doing load-bearing wall and structural work is so intimidating for a lot of contractors. So this is why we're making this video, so that you guys can have the knowledge to do this kind of work yourself and be successful. Because to get from the drawing to the finished step, it's all up to you. No one's gonna teach you how to get there. And I want you to be able to do it safe, all right? Don't want something falling on your head. So let's go take one more quick look at what we've got here, and then we'll start doing the demo and the rebuild. All right, for the purpose of saving a little time in the video, I just went ahead and I set this up. I'm gonna talk you through it now. Remember our design, we have one single wall. Now, this single wall needs to pick up both floor joist packages, all right, and at least 3 inches of them. So there are 2 joists here that line up in the same spot. You can see by the laser where this is the overlap section from here to here, from here to here, all right? That's why I set my laser line up right on the edge of those so that I can pick up this joist to this plus this joist location. Everything else crosses over. all right? So for the whole 10 feet of wall, we will pick up both floor joists. It's a perfect location. So that's why I use a laser line to draw that up, all right? Square that off on the wall. Now I've got my 2x4 plate, and it's gonna go on that red line. Okay, fantastic. Building code requires that if you're gonna be in contact with the concrete, you gotta go pressure treat it. Now, this is my forever home, so I'm gonna go above code, okay? What I'm gonna do is I'm gonna add a sill plate to this as well to have separation. And I'm gonna maintain the pressure treated lumber because I have to build structural walls before I put any subfloor system in at all. And I wanna make sure that I'm creating an environment where this is never going to be subject to rot, no matter what kind of water conditions we get down here. Because I can't put all these walls on a subfloor system to isolate them from water events. I want to protect them from water events by having them be pressure treated. I am using a hammer staple, T50 1/2-inch staples, all right? What we're gonna do is we're just gonna staple this on. Now this comes flat on one side and grooved on the other. It's textured, okay? The texture side is designed to go in contact with the concrete. It's an unstable surface. It has texture. So by putting the ridges on, by putting the ridges on the concrete, you create an environment where under compression, create an environment under the compression of the weight of the wall. Every one of these grooves has an opportunity to air seal. Down there, not as important, but just good practice to install it the right way. Time for a new blade too. Oi, oi, oi. Always work from the middle. All right, so before we nail this down, I want to go through one more element of this build. Now, I've talked through this with my engineer because instinctively, you're going to want to put your beam across and then a post over here. The problem with putting a post against the concrete is it's going to interrupt with your thermal system. Because my system for doing a basement is quite simple. I want an 1.5 inch R7.5 board, rigid foam on the outside wall with an airspace. So I won't be able to stick my finger behind it, okay? But I have to maintain that gap before my stud wall goes in contact with it, okay? So I push it, okay? Give myself a 1/2 inch airspace. Now I can slide that out of the way, knowing that I can get my thermal barrier in there and not have a thermal break. A thermal bridging. A thermal break is when you have the same material all around the whole building, okay? Thermal bridging is when you're swapping out materials that have different R values and you create cold spots and drafts. Drafts can lead to condensation and condensation goes to mold. So whenever you can avoid that whole process from happening, it's good building science. And because today we were required where I live to have an R20 wall assembly, whenever you have a weakness or a failure in that, it is really easy to get a bad draft and cause a condensation. So we want to be really smart about our process. Now that plate now goes here. I want it directly beneath my laser line up top. So I'm going to hold my hand here, give that a bit of a nudge. When it's perfect, it's perfect. And until it's perfect, it ain't perfect. Okay, we're transferring load. The more direct we can be and intentional, the better. There we go, I've got that in now. I'll go back and double check. Because when you're moving things, hey, nice. All right, now, we're gonna make some noise, okay? Because we're gonna use our impact gun. Always put the nail in first. Orange gasket at the very end. Push it into the pipe and it will compress and hold it in place really well for you. Now you take your .22 caliber bullet, all right, and you put the little pointy tip down, okay, just like a gun. Bloop. And because we're going with a beam, I'm going to have 3 or 4 2x4s. I'll check the drawing again to find out how many. I'm going to give myself a little bit of distance here before I put my first fastener. Here we go. Now I push it down until I hear it really close. One strike with the hammer. There we go. Drop out your shell casing. All right, that's now garbage. And move along here. I want to put in one of these fasteners every 3 or 4 feet. Get rid of the casing. Okay. Now, some of you are saying, wait a minute, Jeff. If you have insulation and then you've got your load point, is that okay? Like, shouldn't it be against the wall to hit the footing? The weight is actually going to get transferred through the concrete, through the stone, right onto the footing. All right? That's what the engineer told me. I'm taking his word for it. So we've got our laser based on our floor joist package. We also want to make sure we mark the joists themselves. Put a V on the side that you can see. Okay? Again, here's my joist. Put a V on the side you can see. So now I know when I'm putting my LVLs in, they go here and here. All right? Nice and simple. Have a few spots for reference, because if you're doing this alone like I am, then you're going to have a couple of tricks up your sleeve. Now for the next trick, we need to go grab ourselves some all-round. My beam here, let's just double check my drawings. B4, 2 ply, 1 3/4 by 9.5. That means I need a strap that is 9.5 twice, 9.5, 10, we'll just go 20, 20 plus 3 inches, boom, plus, that'll just be to wrap the beam. Plus I need a few inches on each side so that I can hang this thing. I'm gonna go with like 8. And then, just because I don't want to make this too hard on myself. Okay, there we go. There's my hanging strap. Okay, now, remember, this is because I'm working alone. And I know it's gonna be about 3.5 inches long. There we go, we're just gonna leave it nice and loosey-goosey. Okay, and I'm gonna go pick in my first LVL and we'll get her installed. Okay, so here's my beam. She's a biggie. Full 10 feet. My process is simple. I'm going to lift this up, hang it in the strap, lift the beam up, get it on the line, and then drive some screws in. All right. They're going to be what we call temporary screws. Now, one of these construction screws will carry 80 pounds. This is not a 160-pound beam, so I'm fine with being in temporary. The whole point of this is it's just I'm working as one man here, so got to have a system, eh? All right, here we go. So LVL literally stands for laminated veneered lumber. And so these are like little pieces of strands, like little pieces of plywood, okay? And each one of those pieces is pressure treated individually and then is laminated together with an adhesive, okay? And that's what creates the beam. So this beam is designed to be twice as strong as a regular dimensional lumber, because this gives me the ability to put doors underneath it in this basement, and I still have the approval of fire code for 78-inch clearance from the floor to the top of the door. Yeah, I'm walking underneath the beam hanging off a couple screws. That makes a lot of sense, doesn't it? All right, here we go. Now, currently 5.5 inches away from where I want to be. So, I got 2 options. I can hang a blocker off the end to guarantee my distance. That could be temporary. Or we'll just readjust on the hanger. Get my 1 through 2 1/4, that is perfect. Same thing. Need an extra pair of hands? You can rent them outside of that mark. Okay, that's a lot closer. Let's get some temporary screws in here. All right. On my line. Okay, my laser line. That's my depth line, my laser line, depth line, and temporarily install it. Come back down here and do the same thing. Okay, now there's my line. Boom. Okay, beam number 1's in. Wow. I think I'll put a couple more temporary screws in here, just to make this a little bit safer. Okay, beam number 2. It talks here about what kind of fasteners, how many to use, how it all works, okay? And basically it's this. It's 2 rows of fasteners, which means a row on this side and a row from the other side to put 2 of these together. That's how you make a beam, okay? And they've got to be 1 fastener for every 2 inches of nominal dimension. So this is considered a 2x8. So I need 4 fasteners on each side, all right? They have to be within 5 inches of the end of the beam, okay? And I'm gonna start it in the middle of my beam on my 5-inch line. Okay, now I'm gonna lift it up, get the bottom of these 2 beams flush. And when I mean flush, I mean sort of flush. And what I'm looking for, because they're at different heights, is directly beneath this point right here. Okay, right underneath my bolt, this point here, this needs to be flush. That's the axis, because the beams are moving, and that won't change. Okay, if I put it flush to this end, then it'll be in the wrong location. So here we go. Let's get this one installed. We have to fasten from both sides as well. So on the other side, here I'm going 5 inches. On the other side, I'll go 4 inches. So I'm not having competing screws butting into each other. All right, and we'll go to the other end, and we'll just lift her up and stick it in place. Again, within 5 inches, well, I'm gonna go here. That's at about 4, so I'm gonna be fine. You know, lift it, flush. There we go. Now it's 1 beam hanging off of 4 screws. So, really important here. I'm going to switch out my bit, put a couple of temporary screws from this side as well. The head doesn't sit on a brand new drill bit. So the next step, now that we got it temporarily supported, is to get it permanently supported. That's why we call it post and beam, because the truth is our structure is intact fully once I have a post on each end. All the other studs we're going to put in this wall is just for the purpose of, well, code, right? Like we want to insulate it for sound, we want to have electrical, got to have a box every 10 feet. So that's just infilling like a temporary wall built inside of a post and beam. If that makes any sense. You're going to notice your LVLs are not going to come the same thickness. It's not going to be perfect, okay? And because they're meeting joists on each side, they're going to be at different heights. There's going to be a lot of variances going on here. So when we're measuring, we're going to be measuring from the plate up to the LVL, okay? And then past it. So we're actually looking at it like that. All right, and we want to get our measurement. Now, in this case, my measurement says 78.5. And that would be perfect, except I can see a little bit of a gap at the top, all right? And what I want to do is I want to compress this and push it right up nice and tight with those floor joists. So once I get the first and the second beam in, I'm going to remove those temporary screws and let everything sit nice and tight on that. And you're going to notice that 2x4s, when they under compression weight, they actually squash a little bit. They get a little bit shorter, okay? So take your measurement, 78.5. Let me double check that I didn't write it down. Do what I say, not what I do. Here we go, 78.5. I'm going to add an 1/8 because this beam is higher than this by an 1/8, all right? And I'm going to add another 1/8 because my beam isn't in total contact with the floor joist. So I'm going to go 78 3/4, believe it or not. And then we are going to drive this bad boy in. I'm going to cut 2 of them to get started with. Then we're going to refer to our drawings about how many boards we need. And then we'll build out both ends. Here's my boards. When I put them together, I notice that this one has a bit of a bow to it. At the top and bottom, there's a gap. See that? Okay. So I'm flipping this one around. And then I'm going to nail them together this way so that the gap is now in the middle. We're going to set it where we want to put it, right here at the edge. And I know from my experience that this is actually going to cause the floor joist to lift. That'll be temporary. We'll settle it all back in a second. All right. And this is really starting to pick up the weight. Lining it up now and hitting it close to the bottom as I can. this is the moment. Want to use a level. In a perfect world, the foundation wall should be level. And it's not perfect. Okay? But our load transfer point should be. All right? So, I'm actually really, really happy with that. All right. Regular nails are bright. And then we've got galvanized nails. Okay? So we get rid of the bright ones. Those are for indoor use only. The package will say so. These ones, galvanized, will actually have the ACQ symbol on it. It's important because this beam up here is pressure treated. You don't put any fasteners in it that are going to be prone to oxidizing and rusting because it's the wrong kind of metal. It's also pressure treated on the bottom plate. So, right now, just to keep things stable, I'm throwing a nail from each side. Okay, that'll keep it from moving around. Okay, now I'm going to go refer to my chart to find out what we're dealing with here, but I want to get at least 2 boards in before I loosen the screws and let everything sit down. Okay, my chart says I need 4 of these, so we're going to get 2 of them in place first, and then we're going to release the weight onto these 2x4s. Okay. The second one is the same size. It should go in a little bit easier. The first one did all the lifting. You can hear the depth of that baritone of the hammer, right? You know that's picking up some load. So now I'm going to screw them together on a bit of an angle so that I can pull them nice and tight. And for good measure, going to nail them all across, right? And that's how we're going to laminate these things. All right, now, before I go and put the other 2 on this end, I'm going to get 2 on the other end. You know, safety first. We want to make sure that we're carrying the weight right. Let's get the measurement over here. Here's 78.5. And again, we want to lift and pick up the weight, I got gap up here, I got gap over here. We do exactly the same thing. We're going to cut it for 78 3/4. And we'll jam that sucker in. Make sure that the bottom plate is compressed to the ground and all the joists are lifted and compressed up at the top. Be right back. Get this close to the end. Okay. When you're doing this, make sure that your stud is directly underneath the joist that it's carrying, okay? Or it'll slide right out the top, all right? Now, I am working way too hard with a small hammer. Let's make quick work of this. I'm still in a good spot up here. Feeling good. Let's go take a look at the level. Yeah, the top can come over a little bit. Nice. That is the money. Let's just get rid of the twist. Okay. Now, when it says 4 2x4s, they don't have to be underneath the joist and in. They can be underneath the joist and out. Okay, so I can actually fill out the overhang here a little bit and add 1 more on the back side. Get closer to flush on the front of this. This will be good. And then I'm also having my design another interior wall right here, coming back to that bedroom door. And it's non-load bearing, so I can use that to fill in any discrepancies. So, in like manner, we want to get it temporarily nailed in place. So that when I'm nailing my next board in, I'm not knocking this one out of position. Okay. Next 2x4 is going a lot simpler, and it does. There we go. Okay, and then the same. We want to screw that middle together, get rid of our gap, and tie it together for good measure. Okay. Now it's just a matter of making sure I've got the right number of posts at each end. So I got to cut 4 more pieces the same length. And stick 2 in that end, 2 in this end. And then there's one more step to do here before we go and add all of our fasteners, because I'm going to pick up a box of the 16Ds. We have to make sure that this can't fold over. Okay? We don't want the rolling action of all that load. All right? So there's a little bit of a structural trick here that we're going to do as our next step to make sure that this is stabilized. So while we're hammering, we don't actually flip our beam over, because that happens and that hurts. By the way, this is a 10-foot length and this is a 9¼ inch beam. If I use that on the rest of the wall, it's actually too thick. Remember I told you the fire code was 78 inches? Remember, and we have a 78.5 inch clearance here. Yeah, I can't add hardly any kind of flooring down here if I wanted to meet fire code for my door. Truth is, just adding a door jamb makes me just under 78 inches from my opening. Okay, so it's good that this is just a separation wall. There's no door in it, but that's why we went to LVL technology here. So to raise up, we only have to have 7¼ LVLs for everywhere where there's a door. We just shorten up the distance and put the footings closer together. No matter what situation you're dealing with, there's a solution to the problem. An engineer can help you get there. All right, use that word again. There we go. All right, well, here we go. It's just too much easy like this, eh? All right. We're gonna get our last of our 4 boards on each side. Okay, there's 4 posts. Woo! Now, the way I like to keep things from rolling around is like this. And this is very, very temporary. Go from the plate, throw in a screw, right from the plate. That 4th stud, a couple of times. And because this is a temporary build, no problem throwing a regular screw into the LVL because it'll be removed within about an hour. And that is going to keep that post from rolling off. You got to put one on each side, on each end, so that it's completely established in like an H shape, okay? Now with everything put in to a minimum spec, I'm comfortable to get rid of my little safety strap here now. It's more of a hindrance than anything. All right, so let's go through this. I now have 4 posts to make a post at each end. Satisfies my specs for 4B on my plan. Carrying my 9½ inch LVLs. And the only thing I have to do left now is brace them so I can finish nailing them all off. All right, so it's 5 nails every 18 inches from both sides. It's a lot of nailing. But if an engineer puts in a report that you've got to use a certain fastener, and then he gives you approval for a switch out, that's fine. But look at the switch out option that I had. I didn't realize when I called him I was buying a 1/4 inch lag. Like, that's ridiculous. And that is far too much fastener for this. I'm gonna end up spending about $500 on hardware. So I sent my son to the hardware store to pick up some 16Ds. I'll continue to finish bracing this, get rid of all the straps in the middle, and when he gets here, we'll add those all in. All right, but as soon as I've got my bracing in place, I'm good to get rid of all my temporary walls, because there is no live load above this other than the joists and plywood right now. I don't even have any other interior walls, so I'm good to open up the space. It's gonna feel good to have all this extra wood out of my way. I'm gonna use my temporary wall lumber to become my temporary brace material. There we go. We'll nail that one there. These temporary screws could actually be causing the joist to be sitting proud. Okay. I'm not worried about this thing rolling over by carrying the light load that it has, but I'm only concerned that while I'm hammering, that could be a problem. And then one here. Yeah, I actually saw that joist sit down. Fabulous. And the reason I'm going to use screws to do all this bracing is because it's easier to remove than it is all the nails. Okay, so again, one end of the plate at the bottom. Some scrap blocking and just simply hang it about a foot down. Okay, 2 screws in there, a screw down here. That should be plenty. But here's what I don't have the luxury of. On a job like this, I don't have the luxury of having a son with experience with doing structural work, so he's learning on the go. And I've got him running around a lot, so I'm still doing some of this myself. And without anybody watching the backside of you, right? You're by yourself, and if anything bad happens, you don't see it happening. So I could be literally standing here, nailing like a crazy man, and the whole time it's starting to break apart, and I don't see it. But having someone else on site, they can be your set of eyes to go, hey, by the way, your bracing's coming apart. You know, you get dialed in, right? Okay, so now it's time to clear all this extra stuff out of the way, and we'll get the right fasteners put in this beam to the right dimension, and we'll be able to call that structurally sound. Get the rest of this stuff out of here. Oh, it's going to be a sweet day. Sweet Mendoza. All right. Oh, that's those 1/4 inchers again. And there. I got to switch my drill bit. No more straps. Listen, because there's no live load on top, I'm just going to, until Matt gets back, I'm going to keep tearing up my structural load wall. The temporary ones, they're no longer necessary. Ouch, I might need to buy a new level. Don't need none of this anymore. All right, all right. Ah, sweet. Let's just beat this to crap. There we go. All right, guys. And just so you know, this sucker's solid. It ain't going nowhere, all right? That's awesome, because now it's time to put in our 16Ds. Now, the engineer reported for 3.5 inch ACQ. Now these ones do not have a stamped head on it, but the head diameter of that nail is related to the thickness and length of that nail, all right? So, plus, I made a video. So if an inspector has an issue, they can refer to the video. Now, within the first 5 inches, right, one at the bottom, oi, and then one at the top, in the middle. Holy Hannah, you know that's gonna be a lot of work, right? This is where the tool you use makes a difference, okay? That's a 14-ounce hammer. All right, that's lightweight. That is a 22 ounce hammer. All right, now let's try this again. Hit it. All right, let's go. Now there is one other tool you can use in this scenario, and that is a palm nailer, okay? I don't have one on site here today, but I have just been motivated to go buy one. I'm pathetic. I'm buying a palm nailer. Man enough to admit I need a power tool, damn it. All right. Trying to hammer in these damn nails.
Really?
Holy crap.
What, 3.5 inches?
Yeah, but it's not easy.
Okay.
I suck with a hammer. How are you?
With a hammer? I'm okay.
Yeah. I'm gonna buy a palm nailer.
You mind if I
We're
get a
looking,
couple
we're
to
looking
try?
at a couple thousand of these things for the whole job. I've only got my 22 down here. You don't have your hammer.
Okay, I'm gonna grab that and give it a shot.
He's got a Milwaukee hammer. He's gonna give it a shot. Yeah,
I see what you mean.
yeah, that's not an easy job, is it? That LVL is tough. Oh, one little slip. I know, it's like a nailing challenge. Can you hand nail an LVL?
I'm gonna be here all day.
So I went back to the drawing board and I said, well, there's got to be another mechanical application here, right? Because we can't use a framing nailer with the 1.13 nail. Maddening. So here we are. I got a Milwaukee palm nailer with an M12 battery, the 3.0, okay? It's actually pretty strong. This is gonna run you about 300 bucks for the battery and the machine, because the nailer comes with a wimpy battery, and we found it didn't work on the nails. So we'll start with a spiral nail and see what happens with that. Oh, okay. It bent under the weight. The gun is too strong for the spiral nails, so we can't use those. And does it work with the common nails? That's still a lot of work, because you got to push that the whole time. And I'm like, that's a lot of fatigue. And I'm like, it's one thing for me to be doing this beam, but I'm looking for a solution for down the road, right? Because I'm putting in a 25.5-foot beam, 16 inches long, laminated 4 deep. I'm gonna have hundreds of nails going into that thing. When we get that beam into our ridge position on temporary supports, I don't want it temporarily there for very long. So I don't want to be sitting up there hammering around for 2 or 3 hours putting that together. So I got back on the phone. I talked to the city inspector and I said, is there a rule, like an unwritten rule, where you guys will pass a beam if I use mechanical galvanized, 3.25 inch clipped head nails? And she said no. And because there are some rules in building construction that we have as an unwritten rule that they just make allowance for because of the conditions, but because this is new construction and we have an engineer, she can't override the stamp. She said, no, you're gonna have to get the engineer to make the allowance. And so we got back on the phone with the engineer who was on holidays, and so somebody else in the office picked up the phone and he sent us an email to confirm that because of the conditions of this beam and the lack of load, because it's not carrying the roof, it's only carrying the inside of the house, he would permit us to do this beam here with these nails. Okay, great, so that solves this problem. But I got to still talk to the engineer for the ridge beam, and I contacted Ottawa Fastener, all right? And they're like, if it exists, they can find it. And I tried to have them source me out an option, because the Milwaukee nailer, which we ended up being allowed to use, but not with bright nails, it's got to be the galvanized option. This nailer takes a 3.5 inch nail. There's room in that track, okay? And it also takes between 30 and 34 degree nails, so a lot of different manufacturers. And this is called the clipped head, okay? It means that the nail is not fully round. It's like a half moon, okay? And so when you drive this one in, the clipped head is visible. And so they do make a full round offset. So I can get it get full round nails in this gun, but they don't make them 3.5 galvanized. So the maddening thing here is the inspector, or sorry, my engineer has got me spec'd out to assemble something that doesn't even exist with the mechanical fastener. I've got to go to hand nailing. Anyway, I'm curious to know what you would think, and if you've had any experience with this, if there's another option, maybe, a different tool company perhaps, that makes something for doing structural nailing. I would love to know. I'm busy, I'm not going to do any research, so I'm hoping you guys can help me out with that. Cheers to next time.